Alright, so in this video, we're going to be going over converting Cartesian to polar. So in the past couple videos, we've been talking about converting polar to Cartesian, and now we're doing the same exact thing, just in the opposite direction. Okay, so we have our three equations that we need to know. X equals r cosine theta, y equals r sine theta, and r squared equals x squared plus y squared. We want to convert 5, 5 to polar, 5, 5 being in Cartesian coordinates. Now, polar coordinates, okay, polar coordinates are r, theta. So the first thing we should find is r, okay? Well, if you think of the r as the resultant, okay, like if you hopefully you have a decent knowledge of vectors, okay, then this problem makes a lot more sense, right? You have your x component and your y component, and your resultant, that's r, right? So you have your x and your y here. So we know that your x is 5, and we know that your y is 5. Okay, that's given to us in the problem. Well, since your x component and your y component are perpendicular, that means you can use Pythagorean Theorem for this. Okay, so we get that 5 squared plus 5 squared equals r squared. So 50 is going to equal r squared. You take the square root of both sides, and r equals rad 50. Okay, great. So that's your r. Now what about theta? All right, and theta is going to be a little bit different. Now, you could just plug in this r and your y and find the angle like that. You can definitely do that. You can also use that tangent equation that I was talking about in the converting polar to Cartesian video. Okay, if you use the fact that tangent theta equals y over x, that might help you too. Okay, that might be a little bit easier in some cases. For this case, right, we have 5 over 5. That's what it's going to be, right? So tangent of theta is going to be 5 over 5. Well, that means that theta is going to equal the inverse tangent of 1. What's the inverse tangent of 1? Well, that's just pi over 4. So we know our theta angle, right, or theta is going to be pi over 4. So we have our r, we have our theta, so we know that in polar, this can be represented as rad 50, comma pi over 4. All right, and that does it for that first problem. So we have our next problem up on the board here. Convert x squared plus y squared equals 4 to polar. Okay, so really, you can just substitute in r cosine theta and then square it for this x, right? I mean, that's pretty much what you could do. And then for y, you can do the same exact thing. So let's do that. We get that r cosine theta squared plus r sine theta squared equals 4. We can, of course, square both of these. We get r squared cosine squared theta plus r squared sine squared theta equals 4. Notice that we have a cosine squared sine squared that we can get by itself by factoring out that r squared. We get r squared times cosine squared theta plus sine squared theta. That's going to equal 4. So since this is 1, we get that r squared equals 4. Take the square root of both sides, we get that r equals 2. Now real quick, what does this r equals 2 graph look like? Well, if we have our polar axis here, and we tick off 1, 2, well, r equals 2 is just going to be a circle, right? So what does that remind you of? Well, that's the same exact thing as x squared plus y squared equals 4, right? It's a circle with the radius of 2. So right, you kind of see how this makes sense coming from that circle, okay? So that's going to do it for this video. In the next video, we're going to be doing some more rigorous examples, okay? So stay tuned for that.
So if this video helped you, make sure you leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for parametric and polar and the next video in this series. See you soon.